Alright guys, we're on to lesson 6, and it's going to be arc length formula in radians, and we talked about radians in the last lesson, so we're going to try to go through this quick. Like I've said with the other lessons, do as much as you need to do so that you understand it. If you get to the point where you think you know what you're doing and you want to stop the video, that's fine. Just got to monitor your own learning and make sure you know what to do. There are a couple of tricky questions towards the end of this in the problem set. So if you want to just fast forward after you get the hang of things to those, that's fine too. But I'm going to go through everything, so we're along for the ride. If you're along for the ride for the whole time, great. Otherwise, enjoy with whatever you need. Okay, so arc length. Arc length, we talked about how it's just a fraction of the circumference. So it's theta divided by 360 times pi d. Pi d being the formula for circumference of a circle. Theta over 360 being just a fraction of that full circumference. We talked what a radian is. A radian is another way to measure angles, and it's a way to measure angles where the length of the arc equals the length of the radius. That is 1 radian measure. So 1 radian, we did yesterday, is found by doing 180 divided by pi degrees, which came out to be 57.2958. So we also talked about how 180 degrees is pi radians and 360 degrees would be 2 pi radians. So our arc length formula of theta over 360 times circumference could be written in radians by doing theta over 2 pi times the circumference. Now when we write the formula as theta over 2 pi times pi d, we can do some simplification here. Now instead of using pi d, we can use 2 pi r because 2 radius lengths equals 1 diameter length. And then if you'll notice what will happen, if I put everything from the parentheses into the numerator with the theta, what happens is the 2 pi's cancel out and we get a much easier formula where the arc length is found by the angle measure in radians times the radius length, which should make sense if you understood what a radian is. So the length of the arc as part of the circumference in radian measure is the number of radius lengths that create the arc, because 1 radian angle is 1 radius length on the circumference. So the total length of the arc would be the number of radius lengths applied to the curve of the circle. Now when we write this formula, what you're going to use next year in A2 and beyond is a formula that teachers call SOAR. Now it's the same formula. It is an arc length formula when the angle is in radians. The S stands for the length of the sector, or arc length. The theta has to be in central angle measured in radians. This only works in radians. And then r is our radius length. So we're going to practice that formula, and then that's it for today. So, simple question. Determine the arc length. Our formula, SOAR. They call it SOAR because the theta looks like an O. So S-O-R, SOAR. So the arc length is what we're looking for. And we're going to plug in our radius length of 10, our radian angle measure of 4 pi over 5, and then just go to the calculator or use mental math to simplify it. And we get 8 pi. So pause the video, try number 2. We're going to use the formula SOAR again. So pause the video, try number 2, and then turn it back on when you're ready for the answer. So we're going to find the arc length with an angle measure in 3 pi over 4 radians and a radius of 12. Do the math, simplify it. Arc length is 9 pi centimeters. Now we have 3 pieces of information in this formula: the arc length, the angle measure in radians, and the radius length. So we could be asked to find any one of those things. So using our formula, we're going to take a radius of 16, find the central angle in radians, and we are given the arc length is 4 centimeters. So we plug in 4 pi for the arc length this time. That goes in for S. We are looking for the central angle, and our radius is 16. So we're just going to divide by 16 and simplify. And if you remember what we did with our radian lesson, pi over 4 is 45 degrees, which means in the example up above, when we did 3 pi over 4, that would be 3 45-degree angles, which means this question used the radian equivalent of 135 degrees. Just a little bit of review. Okay, number 4. Find the radius this time. We're still using the same formula, but this time we are finding the radius. So our arc length is 62.5. Our central angle is 5 radians. So we're just going to divide by 5 to get the radius length, and we get 12.5 feet. Now we go to the problem set, do a couple practice problems. What I would like you to do is pause the video, do these problems either one at a time and check, or do them all and then check. But try them on your own first, then come back to the video, and I'll go through them. You'll see if your answers are correctly. But I'm going to go through these a lot faster than the other examples. Just basically show the answer to see if you did it right or not. So pause it, try it, then come back. All right, so the first one should have gotten 3 radians. You're given an arc length, given the radius, find the angle, and the answer is 3. I mentioned in the radian lesson, you do not have to label the radians as the units, because if it's not degrees, it's automatically by default radians. So you could have just put theta equals 3. Number 2, 21 pi centimeters. This one, we are looking for the arc length. The length uses the units of centimeters for this particular question. It is a linear unit, so we just leave it 21 pi centimeters. Number 3, this time we're looking for the radius. So I multiplied times 3, divided out the pi, I get my radius is 30. Once we have the radius, then we can answer the question for the diameter, and the diameter would be double that, so it's 60. Number 4 is one of the tricky ones that I mentioned earlier in this video that you might want to get a little assistance in. You have to be careful here because the length is given as 45 degrees. Okay? So if it's a degree measure, what we have to do is use the old school formula where it's 45 out of 360. The other option is convert the 45 into radians, which would be pi over 4, and then use that. You can do it either way, and we should end up all with the same radius length of 36. Similar thing's going to happen with question number 5. Our central angle is given as 70 degrees. The arc length is 7 pi over 5 centimeters. But because our angle is in degrees, we have to use the old school formula by 70 over 360. Since we're looking for diameter instead of 2 pi r, I just used pi d for my length. Do the math, get your diameter. And number 6, we are going to use arc length PQ of 10 centimeters to find the arc length of QR. What we need to do first is find our radius. So once we are use the 90-degree angle and our 10 pi centimeters in the excuse me, in the formula from last week for arc length, we can use that to solve for our radius length. And then once we have the radius length, we can use our radius to answer the question. Now our radius length looks weird. It's 20 over pi for our radius length, but you know, it is what it is. It's just math. Put the numbers in the right place, into the right formula. Things just work out really beautiful. So our radius length is 20 over pi. The angle measure for that small little sector is 6 degrees, so it's 6 over 360. It's in degrees, so I have to use the other formula. And then we get 2/3 centimeters for that little arc length of QR. All right, guys, we are done. Under 10 minutes, did all the problems. That's fantastic. Good work. Hope you're all doing well, staying safe, enjoying what sunshine we get, and take care. Talk to you soon.